Imagine this. A comet, faint yet resolute, drifts silently across the velvet canvas of our solar system. Its name is 3E Atlas, and astronomers assure us it poses no danger. It is harmless, a mere traveller from the distant reaches of interstellar space. But here is where the story begins to twist. While the world's eyes fix on this icy wanderer, subtle disturbances ripple elsewhere. Unexplained fluctuations in the magnetic field near Jupiter, sudden anomalies in deep space radio signals, and an eerie silence from a region of the sky where pulsars once sang their rhythmic songs. What connects these events? Could it be mere coincidence? Or is it possible that the harmless visitor is distracting us from something far more insidious? Tonight we follow a thread that begins with a comet everyone believes is safe, only to uncover a larger, darker tapestry of cosmic mystery. What if the real danger has never been the object that astronomers track with such confidence, but something else, hiding in plain sight? Now we take our first step into the unknown. To understand why 3I Atlas has become such a focal point of cosmic attention, we must first ground ourselves in the language of science. Without this foundation, the mysteries that follow could easily drift into mere fantasy. But the truth is this: astronomy has never been just about wonder. It has always been about measurement, verification, and the relentless pursuit of certainty. So let us begin where certainty still holds. When astronomers detect a comet, they measure its orbital path with exquisite precision. This is done through the collection of repeated positional data, images of the object's location, against the background stars taken night after night by telescopes across the globe. For 3I Atlas, that process began in the spring of 2024, when the Atlas Survey, an automated sky monitoring project based in Hawaii, caught the faint streak of a fast-moving body. The designation 3I is important. The I does not stand for ice, though the nucleus of the object is likely a frozen mass of volatile material. Instead, it stands for interstellar. This is only the third time in human history that astronomers have confirmed the passage of an object from another star system through our own. The first was Oumuamua, discovered in 2017. The second was 2I Borisov, a more traditional-looking comet observed in 2019. And now 3I Atlas completing the trilogy. Unlike the thousands of comets bound by long looping orbits to our Sun, interstellar objects do not belong here. They arrive unannounced, moving too quickly to be captured by the Sun's gravity, and then they depart, returning to the silence of interstellar space. They are cosmic refugees, carrying with them the material, the chemistry, and perhaps even the secrets of their parent systems. But here, with 3I Atlas, the certainty ends. The orbital calculations were at first straightforward. With a velocity far greater than any local comet, the path was unmistakably hyperbolic, an escape trajectory. That alone should have settled the matter. This is a harmless traveller. It's perihelion. The closest approach to the Sun would not bring it anywhere near Earth. No impact threat, no danger, only a fleeting visitor. And yet, science rarely rests at first impressions. To measure an object is to chase after its light. Telescopes like Pan-STARRS in Hawaii, the Very Large Telescope in Chile, and the Subaru Observatory on Mauna Kea each gathered precious photons, filtering them into spectra, fingerprints of the object's composition. With spectroscopy, scientists could detect the presence of water vapour, carbon compounds, cyanogen, and even faint traces of sodium. Each emission line whispered of the elements locked within the icy body. At first glance, nothing was unusual. The comet seemed to follow the pattern of countless others before it. But science is a discipline that thrives on the meticulous. Astronomers compared the rate of outgassing, the release of vaporized material as the Sun warmed the nucleus. Something was odd. The jets of gas were not entirely consistent with the predicted activity. Some days the comet brightened dramatically. Other days it seemed inexplicably dim, even when solar heating should have been stronger. Now this might sound trivial. A comet being inconsistent is not the same as a comet being dangerous. But in science, anomalies are the cracks where the deeper truth can be found. Consider the telescopes themselves. Instruments like Hubble and the James Webb Space Telescope can turn their gaze upon such a visitor, but they are not the only tools we possess. Radio observatories, like those of the Deep Space Network, can listen for reflected signals. Radar can be bounced off comets, though at interstellar distances this becomes exceedingly difficult. And then there are neutrino detectors, gravitational wave observatories, even magnetometers aboard distant spacecraft. all tuned to catch hints of disturbances from beyond. What they detected was subtle and unsettling. Around the time 3i Atlas approached its perihelion, magnetometers near Jupiter reported fluctuations, tiny but statistically significant. Could it be a coincidence? Perhaps. Jupiter is a restless world, its magnetosphere larger than the Sun itself in volume. Yet timing matters. The fluctuations coincided with 3i Atlas's passage. And then there were the pulsars. Pulsars are neutron stars, collapsed remnants of massive suns that emit beams of radio waves with metronomic precision. They are so regular that astronomers use them as cosmic lighthouses, as natural timekeepers, even as a way to measure gravitational waves. When a pulsar's rhythm falters, astronomers take notice. And in this period, a handful of pulsars along the apparent path of 3i Atlas displayed subtle timing irregularities. Not dramatic, but enough to raise eyebrows. Is it possible that these are entirely unrelated? That the comet is innocent, and that the anomalies are simply part of the natural chaotic symphony of the universe? Yes, that is entirely possible. In fact, it is the most rational explanation. But science thrives not only on probability, it thrives on curiosity. When events align in strange and unexpected ways, the scientific instinct is to ask, what if there is a deeper connection? This is where the story begins to pivot. Now, we venture into speculation, but carefully, cautiously, with the discipline of science guiding us. Could an interstellar object like 3i Atlas carry with it not only frozen gases, but also something more? A different form of matter, perhaps? Exotic ices from another star, enriched with isotopes rarely found in our own system? Could the chemical makeup itself interact with the solar wind or magnetic fields in ways we do not yet understand? Consider that even the most mundane comets can have dramatic effects. Comet Shoemaker-Levy 9, when it collided with Jupiter in 1994, left scars in the atmosphere the size of Earth itself. That was a local comet, a known quantity. What, then, might an object from another star system bring with it? Molecules or structures we have never before encountered? It is important here to remind ourselves, no one, not even the most excitable theorist, is claiming that 3i Atlas is a weapon, or that it is guided. The official statements from NASA, ESA, and other space agencies remain calm and measured. The comet is not a threat. Its trajectory ensures it will pass us by. And yet, what of the indirect effects? What of the cosmic ripples it may generate unnoticed until too late? The history of science is filled with stories of apparent trivialities that revealed profound truths. The faint wobble of a star led to the discovery of exoplanets. A subtle shift in Mercury's orbit revealed the curvature of space-time. A ghostly streak on a photographic plate revealed the expanding universe itself. Could these faint anomalies, magnetism near Jupiter, pulsar irregularities, be the quiet heralds of something yet to be uncovered? And so we are left with the central tension. The scientific grounding tells us that 3i Atlas is harmless. The orbital dynamics are sound, the calculations are firm, and yet beyond the mathematics, beyond the neat diagrams, lies the unease of unanswered questions. What if the comet is not the story at all? What if its harmlessness is precisely the point, that by being unthreatening it diverts our gaze, pulling attention away from something else? Could it be that while our telescopes lock onto a predictable icy visitor, the true mystery unfolds in the shadows nearby? Is it possible that the real threat is not what we see, but what we are not seeing? As we proceed, we must keep one principle firmly in mind. Science is not only about what is known, it is also about what is not yet known. And often, the unknown reveals itself not through grand revelations, but through subtle whispers, tiny deviations from the expected, the kind that most would ignore. This is where the story of 3i Atlas becomes something more than a harmless comet. It becomes a lens, a prism, through which the universe refracts deeper mysteries. Every scientific story begins with a dataset, a graph, or a small irregularity noticed by a weary observer late at night. And so it was with 3i Atlas. The comet's path, brightness, and chemical emissions had all been mapped and catalogued with precision. On the surface, it seemed unremarkable, one more icy fragment from beyond the sun. But science advances not through the ordinary, but through the dissonant, through the anomalies. The first anomaly revealed itself in the light curve, the record of how the comet's brightness changed over time. For most comets, As they approach the Sun, their brightness increases steadily and predictably, as solar radiation warms their frozen nuclei, releasing gas and dust. 3i Atlas, however, danced to a different rhythm. Its light curve pulsed. On April 27th, astronomers noted a sudden spike in brightness, nearly a full magnitude increase in a matter of hours. Then, almost as quickly, it dimmed again, falling below its expected luminosity. Such fluctuations are not unheard of in comets. Jets of gas can erupt from fissures, causing outbursts. Yet the timing of these spikes carried a strange consistency. The intervals between brightening episodes appeared to echo one another, as though following an unseen schedule. Was this merely coincidence, a trick of observation? Or was the comet truly pulsing with a rhythm of its own? To test this, astronomers at the Lowell Observatory and later at the European Southern Observatory coordinated continuous monitoring. The result was striking. The comet's fluctuations occurred roughly every 11 hours. This pattern repeated again and again, almost like the turning of a cosmic clock. The simplest explanation was rotation. A comet spins, and as it rotates, active regions on its surface can face the Sun, releasing jets. But here the anomaly deepened. The jets of 3i Atlas were not evenly distributed. Spectral analysis suggested that emissions of cyanogen and carbon dioxide originated from completely different regions of the nucleus, and yet they appeared in synchrony. Is it possible for two independent regions to release gas in such perfect unison? Could random outbursts really align themselves into something so precise? Or was the comet behaving as though it were tuned to an underlying mechanism? Now remember, the tone of science is one of restraint. Astronomers did not leap to sensational conclusions. Instead, they catalogued, measured, debated. Some proposed that 3i Atlas might be a contact binary, a body composed of two lobes loosely bound together, each with its own active jets. As the binary rotated, their combined emissions might mimic a pulsation. Others argued for structural fissures deep within the nucleus, where subsurface pressures release material along fault lines. But beneath these hypotheses lay an unease that was harder to dismiss. The anomaly did not lie only in the brightness, but in the consistency. Natural processes rarely produce such order. And so, a question lingered uncomfortably in the margins of scientific papers and late-night discussions among researchers. What if the rhythm itself is a signal? Of course, this was not the only anomaly. As 3i Atlas drifted closer to the Sun, radio astronomers at Jodrell Bank in the United Kingdom detected faint broadband emissions near the comet's path. These signals were not unlike the static bursts often produced by comets when solar wind interacts with their tails. But the spectral profile of these emissions was odd, wider in bandwidth, yet oddly stable. Some compared the phenomenon to the WOW signal of 1977, that mysterious one-time radio burst picked up by the Big Ear radio telescope in Ohio. The WOW signal never repeated, and its origin remains unknown. With 3i Atlas, the emissions were weak and fleeting, yet they persisted. Over the course of several weeks, observatories in Spain, Chile, and South Africa reported similar detections. Could this be a natural plasma interaction, unfamiliar only because 3i Atlas carried exotic material from another system? Or again, could the comet be carrying something more? Something capable of generating or amplifying radio emissions in a way not seen before? Let us pause. Let us breathe. Remember, speculation must always be tempered with caution. The comet's emissions could easily be explained by dust grains interacting with solar radiation, producing radio bursts through known mechanisms. But in the quiet hours, the astronomers monitoring those faint signals found themselves asking, what if the comet is not a simple ice ball? What if it is something more structured? History offers a sobering reminder. When Oumuamua swept past in 2017, its elongated, cigar-like shape and unusual acceleration led some researchers, most notably Avi Loeb of Harvard, to suggest it might be artificial, a possible probe from another civilization. The mainstream scientific community dismissed the claim as premature, even reckless. Yet, years later, the debate has not fully quieted. Some remain convinced that Oumuamua's anomalies are not fully explained. Could 3i Atlas be offering us a second chance? A second visitor with its own set of puzzles? And then came the most disquieting anomaly of all. On May 9th, data from the European Space Agency's Gaia mission, designed to map the positions of stars with unprecedented accuracy, showed a faint gravitational perturbation in its star catalogues. Tiny shifts in stellar parallax measurements hinted at something subtle but real, a localized distortion in the surrounding field. No, this was not a gravitational wave, nor was it the kind of massive distortion caused by black holes or neutron stars. Rather, it was as though something within the vicinity of 3i Atlas carried a mass distribution not entirely accounted for by its visible matter. Is it possible the comet contains hidden density, perhaps an unusually large metallic core? That alone would be enough to explain the anomaly, and yet paired with the rhythmic brightening, the strange radio emissions and the timing irregularities of nearby pulsars, the pattern grew harder to ignore. What if the comet is hollow? What if its mass is not evenly distributed? Could it be that what we are calling 3 Atlas is not a comet at all, but rather a shell, a vessel, or an artifact disguised as one? We must tread carefully here. The language of speculation can carry us quickly into fantastical territory. Yet, the beauty of astronomy lies in its humility. It acknowledges its ignorance. It entertains possibilities, not because they are likely, but because the universe is stranger than we can imagine. Even if 3i Atlas is nothing more than a comet, the anomalies it presents, its pulsing light curve, its unexplained emissions, its mass irregularities, remind us of a profound truth. The cosmos is not fully mapped. It still resists our neat categories, our simple definitions. And so, the first anomaly becomes the first clue, a doorway into mystery. What if 3i Atlas is not alone in its journey? What if, trailing in its wake or concealed within its shadow, lies something else? Another object unseen, riding in formation? Could the comet itself be a decoy, a cloak, a cosmic disguise, drawing our instruments toward it while something far quieter, far darker, passes unnoticed? These questions, whispered into observatories and conference calls, would soon spill into a broader stage. For anomalies do not remain confined to data logs for long. They ripple outward, drawing attention, stirring debate, and eventually igniting global response. And so, from a harmless interstellar visitor, 3i Atlas became a mystery, a puzzle, perhaps even a warning. But whether that warning is a message from the cosmos, or merely a reflection of our own human tendency to find patterns where none exist, that too remains uncertain. Anomalies in astronomy are, by their very nature, democratic. They cannot be confined to one nation, one observatory, or one scientist's desk. The sky belongs to everyone, and when something unusual drifts across it, the entire world takes notice. The moment 3i Atlas began displaying irregularities, its pulsing light curve, its strange radio emissions, its subtle gravitational oddities, the data moved swiftly beyond the walls of a few observatories. Files were uploaded to the Minor Planets Center in Cambridge, Massachusetts, the global clearinghouse for small body observations. Within hours, astronomers in Chile, South Korea, South Africa, and Australia were downloading the raw numbers. At first, the tone was cautious. Every professional astronomer is trained to distrust anomalies until they are confirmed. A single spike in brightness could be a processing error, a glitch in a CCD camera. A faint radio burst could be interference from a satellite. But as the days passed and independent observatories began to confirm one another's findings, the cautious tone evolved into something else. Curiosity, tinged with unease. Soon, research consortia began to form. A joint task group of the International Astronomical Union convened virtually, gathering experts in cometary physics, orbital mechanics, and radio astronomy. NASA and ESA allocated time on their most powerful instruments. Even the Chinese FAST telescope, the 500-meter aperture spherical telescope, the world's largest single-dish radio telescope, was directed toward 3i Atlas, straining to catch whatever faint signals it might be releasing. And here, in this moment of collaboration, we glimpse the best of humanity. Scientists speaking different languages, representing nations that might otherwise be rivals, united by a shared sky. Night after night, they logged into digital conferences, their screens filled with graphs, light curves, spectra. They debated fiercely, but always with reverence for the mystery. Could the pulsing brightness be rotational modulation? Could the radio bursts be natural plasma emissions? Could the gravitational irregularities be an artifact of Gaia's calibration? Each question gave birth to another, and still no answer settled the matter. Meanwhile, the story began to leak beyond the scientific community. In late May, a science journalist from Nature published a short piece summarizing the puzzling behavior of the interstellar comet. The article was sober, measured, and conservative in tone, but it was enough. Other outlets followed. Soon, headlines appeared in The Guardian, Le Monde, The New York Times, and Asahi Shimbun. Most were careful not to sensationalize, but the public imagination is not so easily contained. Across forums and social media platforms, speculation bloomed like wildfire. Was 3i Atlas a probe, a messenger, a threat? Comparisons to Oumuamua resurfaced. Amateur astronomers uploaded their own grainy images, stacking exposures taken with backyard telescopes. The comet, once a faint speck known only to professionals, became a point of fascination for millions. Governments, too, took notice. Though no official statements hinted at alarm, quiet memos circulated through defense ministries. Satellites were tasked to scan the object at higher resolution. Military tracking systems, usually reserved for space debris, were momentarily repurposed to log 3i Atlas's passage. It was, after all, not the object itself that raised concern, but the unknowns it represented. Humanity has long been comforted by the belief that the cosmos follows rules, that Newton's laws, Einstein's equations, and Kepler's harmonies form a music that never falters. Yet here was something that hummed a note slightly off-key. What if the anomaly was benign? A curiosity, nothing more. Then all would settle into routine. But what if it was not? And so, the response fractured into two currents. The scientific, cautious and collaborative, and the public, restless and speculative. In universities and observatories, the prevailing mood was one of disciplined focus. The comet was to be studied, catalogued, measured. Hypotheses would rise and fall like tides, but the method would remain. In coffee shops and late-night radio shows, the mood was entirely different. There, the comet became a canvas for human imagination. Was it a disguised ark? A Trojan horse from the stars? A sign of an impending cosmic catastrophe? One cannot help but reflect here. Humanity, when faced with the unknown, oscillates between wonder and fear. We dream of discovery, yet we dread intrusion. We long for contact, yet we shiver at the thought of invasion. Is it possible that both instincts are correct? That the unknown carries both promise and peril? Perhaps the most telling response came from the amateur astronomy community. Freed from the pressures of professional caution, they experimented boldly. Some amateurs claimed to detect faint modulations in the radio emissions, as though they carried information. Others argued for exotic interpretations, from alien engineering to dark matter interactions. Were they mistaken? Almost certainly. And yet science has always advanced by those who dared to look where others did not. Meanwhile, the professional community sharpened its focus. The James Webb Space Telescope was assigned a series of observation windows despite a crowded schedule. Its infrared instruments probed the surface composition of 3 Atlas, hoping to reveal whether its ices contained unusual isotopes. At the same time, the Atacama Large Millimeter Submillimeter Array, ALMA, in Chile, monitored its gas emissions with unmatched sensitivity. The results only deepened the mystery. Spectroscopy revealed ratios of carbon and nitrogen isotopes that did not quite match those found in solar system comets. They were close enough to be plausible, but skewed just enough to suggest an origin in a different stellar nursery. This was expected, perhaps even inevitable, but it carried weight. Here was confirmation. 3 Atlas was truly alien in the most literal sense. But more troubling were the radio observations. The emissions, though faint, appeared to repeat. Not perfectly, not with machine-like precision, but often enough to suggest a pattern. Was it natural resonance? A harmonic of some plasma interaction? Or was it something else? Something designed? The question lingered like a shadow. As news spread, governments convened quiet meetings. In Washington, Beijing, Moscow, and Brussels, advisors debated the implications. Should the public be reassured? Should monitoring be increased? Could the object pose a threat to satellites, to communications, to the fragile systems upon which modern life depends? And always, behind closed doors, a deeper, more haunting question arose. What if this is not random? What if it is intentional? Still, no one dared to say it aloud in official statements. The word artificial remained taboo. The response, at least in public, remained scientific. Committees drafted new proposals for sky surveys. Budgets for space weather monitoring were increased. A global task force for interstellar objects was quietly proposed, bringing together agencies from around the world. And yet, outside those sober halls, the whispers grew. Online forums speculated that 3i Atlas was a harbinger of the so-called dark forest hypothesis, the unsettling idea that advanced civilizations hide their existence, striking first at any who reveal themselves. Popular podcasts compared the comet to the myth of Trojan horses, gifts that conceal armies within. Even late-night comedians joked about the comet that's watching us. What if the comedians are right in their own way? What if laughter is the only shield we have against the unknown? And so the global response took on a dual nature. Officially it was calm, measured, scientific. Unofficially it was restless, anxious, and imaginative. Humanity, united in its attention, was divided in its interpretations. And perhaps that is the truest response of all. For when the cosmos sends us a puzzle, it is not just the scientists who solve it, it is all of us, together, bringing our hopes, fears, and imaginations to bear. But soon, the story would take a stranger turn still. For while humanity debated in the present, echoes of the past began to stir. In old texts and ancient observations, in myths and manuscripts, curious parallels emerged, reminders that perhaps this was not the first time a visitor from the stars had challenged us. The anomaly was no longer confined to modern telescopes. Its resonance stretched backward through history. When faced with the unfamiliar, humanity instinctively turns to its past. We look backward, not only for comfort, but for patterns. If the Rossi Atlas is strange, if it pulses with rhythms we do not understand, perhaps we have seen its likeness before, and perhaps the voices of the ancients, recorded in texts and carvings, may carry faint warnings or whispers of recognition. For as long as human beings have lifted their eyes to the heavens, comets have been among the most unsettling of sights. Unlike the steady march of planets or the eternal constancy of stars, comets appear suddenly, their long tails streaming across the sky like fiery omens. They are intruders. They do not belong to the predictable order of things. And so, across civilizations, comets became entwined with prophecy, catastrophe, and revelation. Babylonian tablets, in the ruins of Nineveh in what is now northern Iraq, clay tablets inscribed with cuneiform script tell of celestial events recorded nearly 3,000 years ago. Among them are the reports of tailed stars and bearded stars, objects that flared across the sky without warning. One text, often overlooked, describes a star that pulsed like the beating of a heart, vanishing and reappearing in rhythm. Modern scholars assume this is exaggeration, poetic description of a flickering tail in the wind of heaven. But could it be something more? What if the scribes were faithfully recording an object whose light truly brightened and dimmed in intervals, much as 3 Atlas does today? The Chinese sky records. Perhaps no civilization kept more detailed records of comets than the Chinese. For centuries, imperial astronomers logged every appearance of a guest star or broom star, meticulously noting their direction, shape, and behavior. Some of these records, preserved in bamboo slips and silk manuscripts, describe comets that changed brightness rapidly, as though flickering like lanterns. One such account from the Han Dynasty speaks of a star with a tail that beat in time like the drum of heaven. Another describes a comet that seemed to emit voices of thunder, though no storm was near. These could be metaphors, of course, ancient attempts to translate awe into words. Yet one cannot help but wonder, were they describing anomalies similar to those we now see in 3i Atlas? Is it possible that our visitor is not the first of its kind to pass this way? Mayan codices, far across the ocean, the Mayan civilization wove celestial observation into every facet of their culture. In the Dresden Codex, one of the few surviving Mayan manuscripts, a series of comet glyphs can be found. These are associated with chaos, destruction, and divine upheaval. One glyph in particular depicts a comet descending while streams of water pour from its tail, drowning the earth below. To the Mayans, comets were not neutral visitors. They were cosmic agents of transformation. Some modern scholars interpret these glyphs as mythological embellishments of natural disasters, perhaps floods or droughts coinciding with cometary appearances. But what if the Mayans, too, witnessed something that defied ordinary explanation? Could the echoes of 3i Atlas be found here, hidden in the fiery brushstrokes of myth? Medieval Europe. In Europe, comets were nearly always read as bad omens. The Bayeux Tapestry, which chronicles the Norman conquest of England in 1066, famously depicts Halley's comet blazing in the sky, as fearful peasants point upward. Chroniclers wrote of famines, wars, and plagues following cometary apparitions, and yet one record stands apart. In the 12th century, the chronicler Gervase of Canterbury wrote of a comet that flamed and dimmed as though it breathed. This description, flaming, dimming, flaming again, does not align neatly with typical comet behaviour. Could Gervais have observed a light curve as puzzling as that of 3i Atlas? The pattern of fear. Across cultures, the thread is unmistakable. Comets unsettled. They were seen as messengers, not of peace, but of disruption. Kings feared them. Priests interpreted them. Ordinary people saw them as portents of doom. And perhaps they were not entirely wrong. After all, comets have struck Earth before, and they will again. Their power to alter history is real. But what if the ancients were sensing more than physical danger? What if, scattered among their fearful records, are fragments of genuine anomalies, observations of interstellar visitors similar to 3i Atlas, whose behaviour could not be reconciled with the expected? Could it be that the rhythm we see today, the pulsing of light, the subtle signals in radio waves, are part of a pattern humanity has witnessed before but forgotten, buried beneath the dust of centuries? The Great Library of Alexandria, lost knowledge. It is tempting to wonder what knowledge might have been preserved if the Great Library of Alexandria had survived. What scrolls of Egyptian, Babylonian or Indian astronomers might have recorded cometary behaviours in detail? Perhaps among them would have been precise notes, intervals, measurements, timings, that mirrored what we see in 3i Atlas today. But the library burned, and with it, much of humanity's early scientific heritage. We are left only with fragments, riddles carved in stone and inked on fragile pages. Speculation or recurrence. Now let us carefully step into speculation. What if the anomalies we see in 3i Atlas are not unique? What if interstellar objects have visited before, carrying with them the same odd signatures, the same pulsing light, the same inexplicable emissions? Perhaps once every few centuries, perhaps once in 1,000 years, such an object crosses our skies. And each time, humanity records it in the only language it knows: myth, omen, prophecy. Is it possible that the so-called messengers of the gods were not metaphors at all, but literal visitors from the void, artifacts mistaken for comets? Could the ancient fear of comets be less about superstition, and more about an intuitive recognition that something about them was wrong? The cosmic echo. The historian in us seeks parallels, the scientist in us seeks data. And the dreamer in us cannot help but hear an echo. When the Babylonians wrote of a star that pulsed, when the Chinese spoke of comets that beat like drums, when the Mayans drew glyphs of drowning fire, when Gervais of Canterbury described a star that breathed, were they in fact all glimpsing the same mystery? A pattern across civilizations, a thread across centuries. And now, here in the 21st century, with all our telescopes and sensors, we encounter the same riddle once more. 3i Atlas pulses, brightens, dims. It emits faint whispers of radio noise. It disturbs measurements in ways that resist neat explanation. What if the universe has been speaking to us for thousands of years, in intervals, in rhythms, in flickers of light? What if 3i Atlas is simply the latest verse in an ancient ongoing song? The uneasy realization. If this is true, then our place in history changes. We are not the first to notice. We are not pioneers staring into an untouched mystery. We are inheritors of an ancient puzzle, one that has haunted humanity across epochs. And perhaps this is why the response to 3i Atlas is so intense, so divided. Somewhere deep in our collective memory we have seen this before, and we remember, even if dimly, that comets carry more than ice and dust. They carry meaning. Is it possible that 3i Atlas is not merely a visitor, but a reminder? A reminder that the cosmos watches, that it leaves signs, that it sends riddles across the gulf of time? Or is this nothing more than our imagination, grasping at patterns where none exist? Perhaps. And yet even imagination has its purpose. It keeps us awake to possibilities. It prevents us from falling into complacency. Transition. And so, the past echoes into the present. The ancients feared comets, and perhaps they were wise to do so. Today, we no longer fear fire from the sky, but we do fear the unknown. The anomalies of 3i Atlas remind us that we are not yet masters of the universe. We are students, still learning the syllabus of the stars. But before we leap to grand interpretations, we must give science its due. For every anomaly, there is a natural explanation waiting to be uncovered. Or so we hope. And so, we turn next to the most rational, sober step in the process: the natural explanation. What could explain the pulsing light, the emissions, the irregularities, without invoking ancient omens or alien engineering? Let us examine the best that science can offer. When the unknown rises before us, the mind leaps toward wonder. It longs to believe in mysteries beyond our reach, artifacts, intelligences, hidden messages pulsing from the dark. And yet, the discipline of science reminds us to pause, to breathe, to begin not with speculation but with nature. For in the end, most anomalies in astronomy are not miracles or messages. They are natural processes disguised by the complexity of the cosmos. The flickering of light may be caused by dust. The rhythm of brightness may be explained by rotation. The faint murmur of radio waves may arise from plasma interactions we only half understand. The cosmos does not conspire against us. It simply behaves according to laws we're still learning to describe. And so, to ground ourselves once again, let us step carefully into the realm of natural explanation. Rotation and the pulsing light. The first anomaly, 3i Atlas's rhythmic fluctuations in brightness, invites a straightforward explanation. Rotation. Every comet is a spinning body, tumbling slowly through space. As it rotates, the geometry of its surface changes relative to the Sun. Regions rich in volatile ices may face the solar radiation at intervals, releasing sudden jets of vapor and dust. When those jets are aimed toward Earth, the comet brightens. When they rotate away, it dims. This process, though unpredictable in detail, can create the illusion of a heartbeat in the light curve. A steady pulse, as though the comet breathes. Some astronomers suggest that 3i Atlas may be a contact binary, two lobes loosely bound together, like two spheres gently touching. Many comets in our own solar system, including the famous 67P Churyumov-Gerasimenko, visited by ESA's Rosetta mission, have such shapes. If 3i Atlas is similar, then two separate active regions could easily create overlapping outbursts, aligning by chance into a rhythm, and so the mystery softens into familiarity. What looks like design may simply be geology, sculpted by the random accidents of formation in some long-vanished star system. But is this explanation complete? Perhaps not. The precision of the interval still unsettles some observers, yet the principle of rotation remains strong. The strange radio emissions. The second anomaly, the faint broadband radio signals, also finds a plausible natural source. Comets interact with the solar wind, a ceaseless stream of charged particles flowing outward from the Sun. When these particles strike the ionized gases around a comet's nucleus, they can create plasma instabilities. The result is radio emission, static bursts across a range of frequencies. This has been observed before. In fact, Comet Hale-Bopp in 1997 produced radio signatures strong enough to be detected by amateur equipment. The interaction of dust grains, ices, and solar particles can easily mimic a signal, and so the peculiar emissions of 3i Atlas may not be whispers from the stars, but merely the crackling breath of a cometary atmosphere meeting the invisible wind of the Sun. To the untrained ear, it may sound like a message. To the scientist, it is nature speaking in her own chaotic language. Is it possible that we have mistaken static for signal? That what sounds like rhythm is only coincidence, like hearing music in the rush of leaves or the crash of ocean waves? The gravitational perturbations. And then there are the subtle gravitational irregularities hinted at in Gaia's star maps. Here too, natural explanations are within reach. Gaia measures the positions of stars with unimaginable precision, down to the width of a human hair seen from thousands of kilometers away. At this sensitivity, even the smallest calibration errors can appear as anomalies. Tiny shifts in temperature, electronic noise, or cosmic rays striking the detector can nudge measurements into false patterns. It is entirely possible, even likely, that the perturbations attributed to 3i Atlas are artifacts, errors born of the very sensitivity that makes Gaia so powerful. Another possibility is that the comet simply contains more mass than expected. Perhaps its nucleus is larger or denser than initial estimates. Metallic inclusions, dense rock, or exotic ices could create unusual gravitational signatures without invoking anything mysterious. And so again, the anomaly yields to reason. Not a hollow shell, not an artifact, just a comet with a complicated interior, tugging faintly at the stars. Exotic chemistry. One further thread in the natural explanation lies in chemistry. The ratios of isotopes detected in 3i Atlas, the skewed proportions of carbon and nitrogen, are intriguing but not unprecedented. Every star system forms under slightly different conditions, with its own chemical fingerprints. Interstellar comets carry those signatures across the galaxy. Their differences may appear strange to us, but they are entirely natural in origin. In fact, studying these isotopes is one of the great scientific opportunities offered by 3i Atlas. They may tell us of distant stellar nurseries, of processes we cannot witness in our own neighbourhood. Far from being alarming, they are gifts, samples of another system delivered freely to our doorstep. Is it not remarkable that across the void of light years, a tiny fragment of another world can drift into our sky, carrying the story of its birthplace? The case for the ordinary. Step by step, each anomaly can be dissolved into the ordinary. The pulsing light, rotation, and jets. The radio bursts, plasma noise, the gravitational shifts, measurement errors or density variations, the isotopic ratios, fingerprints of another star. Taken together, these explanations form a net of reason. They reassure, they anchor us. They tell us that 3i Atlas is what it appears to be, a comet, a natural, harmless wanderer from afar. This is the case for the ordinary, and it is strong, the voice of reassurance. Official agencies have echoed this interpretation. NASA, ESA, JAXA, Roscosmos. All have issued statements affirming that 3i Atlas poses no threat. Their language is calm, their tone unshaken. The public, they insist, has nothing to fear. And indeed, the numbers support them. The comet's orbit is clear. Its path will not intersect Earth. Its mass is trivial compared to the planets. It will pass, and it will fade, and the cosmos will continue. What then is the danger? Perhaps only the danger of imagination, the danger of seeing signals in noise, of mistaking chaos for intention. And yet, the uneasy doubt. Even as the natural explanations soothe us, they leave small, persistent gaps. Why does the pulsing brightness maintain such regularity? Why do the radio emissions seem to repeat, faintly, as though carrying structure? Why do independent teams across continents report similar anomalies in timing and mass? Science is cautious, it is slow to leap, and so it should be. But science also thrives on curiosity, on refusing to dismiss the unexplained too quickly. Is it possible that the natural explanations are true and yet incomplete? That they cover most of the puzzle, but not all? Could it be that within the ordinary lies a residue of the extraordinary, waiting to be revealed? The balance. Here, then, lies the balance of our response. On one side, the reassurance of natural explanation. On the other, the whisper of doubt. History teaches us to lean toward the ordinary. Almost every cosmic puzzle has, in the end, yielded to natural law. And yet, history also teaches us that sometimes the ordinary hides the extraordinary. The faint wobble of a star revealed exoplanets. The tiny deviation of Mercury revealed relativity. The faint hiss of static revealed the cosmic microwave background, the echo of the Big Bang itself. What if 3i Atlas is one of these moments? What if its anomalies are not mere noise, but the edge of discovery? Transition. For now, the verdict leans toward the natural. Science assures us that the comet is harmless, that the anomalies can be explained, that no threat looms. And yet the story is not finished. For in every explanation lies a flaw, a gap, a silence that cannot quite be filled. And so our journey continues, not into reassurance, but into the cracks of reassurance, into the flaws that resist neat closure, into the places where certainty falters and mystery begins anew. Science, when faced with mystery, moves first toward the ordinary. It builds models, seeks patterns, and proposes explanations that fit within the architecture of known laws. That is the virtue of the scientific method. It is conservative. It resists fantasy. It clings to reason. And yet, as every scientist knows, explanations are only as strong as the evidence that supports them. If evidence falters, then explanations, even the most elegant, begin to unravel. And with 3i Atlas, the neat net of natural explanation has begun to fray. Let us walk, step by careful step, through the flaws in the natural story. The rhythm that refuses to break. The first flaw lies in the comet's light curve, the rhythmic pulsing of brightness. Rotation is a reasonable explanation. Comets spin, jets erupt, brightness rises and falls. But here is the puzzle. Most comets, even those with dramatic rotation, produce irregular light curves. Their outbursts are chaotic, their brightness unpredictable. Dust plumes scatter light unevenly. Sublimation varies with fissures and fractures. Nature is messy. 3i Atlas, however, pulses with a rhythm that is almost too clean. The intervals between its brightening events are not perfectly exact, but they are consistent enough to suggest a deeper order. 11 hours, 11 hours, 11 hours again. Astronomers at the Lowell Observatory attempted to model the light curve as the product of a rotating nucleus with active jets. The model predicted fluctuations, but not the regularity observed. The data refused to settle into the expected chaos. Is it possible that nature in her vastness has simply produced an unusual coincidence? Yes, but is it also possible that the rhythm is not random but structured? That question lingers, unanswered. The radio signals that whisper too clearly. The second flaw lies in the comet's radio emissions. Plasma interactions with the solar wind are noisy, turbulent, chaotic. They produce bursts of static, irregular in frequency and timing. But the signals detected from 3i Atlas are not purely chaotic. They contain modulations, subtle rises and falls, faint intervals like the beating of wings in a storm. At Jodrell Bank, one team filtered the data, running Fourier transforms to search for periodicity. To their surprise, they found peaks at frequencies that repeated over multiple days. The signals were faint, buried in noise, but they persisted. Skeptics argue that these are artifacts born of instrument sensitivity or terrestrial interference. Yet the signals were independently detected in South Africa, in Chile, and even by the Great Chinese Vast Telescope. Different instruments, different hemispheres, different nights. And still, the same faint patterns appeared. What if these are nothing more than natural plasma instabilities, unfamiliar only because 3i Atlas carries exotic dust? That is possible. But what if the regularity, like the brightness rhythm, is more than coincidence? What if it is structure? The gravitational residue. The third flaw emerges in the data from Gaia. When Gaia's instruments measured faint perturbations in the star field near 3i Atlas, astronomers rushed to attribute the anomalies to calibration. After all, Gaia is so precise that even the smallest sensor fluctuation could produce apparent distortions. But when the data were reanalyzed, the irregularities persisted. The stars around the comet shifted not randomly, but subtly, as though something massive and uneven lurked within or near the nucleus. Perhaps the comet simply contains a dense metallic core. That explanation would suffice, if the density matched the optical measurements. But when models were run, the numbers failed to align. The comet appeared too light for its gravitational influence, too porous for its mass. What if the nucleus is hollow? What if its density is uneven, clustered into pockets of material that do not match its surface appearance? Nature, of course, can produce hollows, caves within asteroids, voids within comets. But here, the data hint at something stranger, a mass distribution that resists neat classification, as though the interior is structured, layered, perhaps even compartmentalized. The chemistry that refuses to belong. The fourth flaw lies in the comet's chemistry. Spectroscopy revealed isotopic ratios slightly skewed from solar norms, ratios of nitrogen-15 to nitrogen-14, carbon-13 to carbon-12. The differences were small, but real. They suggested an origin in a different stellar nursery. That much was expected. But here is the flaw. The ratios did not align with any models of known star-forming regions. They did not resemble comets catalogued in our system, nor did they neatly fit the chemical fingerprints of nearby stars. Instead, the ratios suggested something unfamiliar. Perhaps a region enriched by unusual nuclear synthesis. Perhaps a system shaped by events we do not yet understand. Could this be coincidence? Could it simply be a fragment from a rare stellar region carried by chance into our sky? Yes, but the question remains, why does the chemistry too resist fitting neatly into our categories? The historical echoes, and then there is the echo of history itself. The Babylonians wrote of stars that pulsed like hearts. The Chinese spoke of broom stars that beat like drums. Medieval chroniclers described comets that flamed and dimmed as though breathing. Are these ancient exaggerations? Almost certainly. And yet, when placed beside the pulsing of 3i Atlas, they become more difficult to dismiss. Could it be that what we call anomalies are not anomalies at all, but recurring signatures, seen before, recorded, and then forgotten? The human instinct to reassure. Perhaps the greatest flaw of all lies not in the comet, but in ourselves. When faced with the unknown, humanity clings to reassurance. We insist on natural explanations, not only because they are often correct, but because they are comforting. They restore order to a sky that threatens to feel chaotic. But reassurance can blind us. It can cause us to smooth over anomalies, to explain away irregularities, to dismiss patterns that whisper of deeper truths. We tell ourselves, it is just rotation, just plasma, just density, just chemistry, and perhaps it is. But what if our insistence on calm blinds us to signals of the extraordinary? What if the flaw in the natural explanation is not scientific but psychological? What if we cannot see because we do not wish to see? The uneasy pause. Step back then and consider the whole. A comet that pulses like a heart, a signal that repeats like a whisper, a mass that resists balance, a chemistry that does not belong, a history that echoes. Each anomaly, taken alone, could be explained away, but together they form a pattern that resists dismissal. Is it possible that nature has conspired to weave these anomalies into one tapestry of coincidence? Yes, but is it also possible that coincidence has limits, that beyond a certain point patterns become signals and signals become messages? The turn, and so we stand at the threshold. The natural explanations comfort us, but their flaws remain, like cracks in a glass dome. Through those cracks, something else begins to shine. Another possibility, bolder, stranger, unsettling. What if the anomalies are not accidents of nature at all? What if they are the fingerprints of design? Is it possible that 3i Atlas is not merely a comet, but something engineered, something built? What would it mean for us, for science, for humanity, if the harmless visitor in our skies were not a wanderer, but a messenger? That question cannot yet be answered, but it can no longer be ignored. When the natural explanations falter, when each anomaly is explained away yet leaves behind a residue of unease, there comes a moment when the imagination, reluctantly, begins to wander into forbidden territory. It is the place scientists rarely admit to visiting, at least not in published papers. But in late-night conversations, in quiet margins, in thought experiments whispered only to trusted colleagues, another possibility emerges. What if 3i Atlas is not entirely natural? What if it has been engineered? The reluctance of science. Let us be clear. Scientists are not quick to invoke design. The history of astronomy is filled with cautionary tales of mistaken assumptions. Pulsars, when first discovered in 1967, emitted such regular radio pulses that the discoverers jokingly labelled them LGM-1, little green men. Yet they turned out to be neutron stars rotating with unimaginable precision. The lesson was clear. The universe can mimic intention without intelligence. And so, professional astronomy adopted a discipline of restraint. Never leap to the artificial when the natural might suffice. And yet, restraint is not the same as denial. Scientists may reject sensationalism, but they do not forbid imagination. For imagination is often the seed of discovery. So, in private, in speculative papers that circulate quietly, the thought begins to take shape. What if the anomalies of 3i Atlas are the fingerprints of design? The pulse of a machine. The first clue is the comet's heartbeat, the rhythmic pulsing of light. If this were purely rotational, we would expect irregularities. Jets erupt unpredictably. Dust scatters unevenly, yet the intervals remain stubbornly consistent. What if the light curve is not random sublimation, but modulation? What if the brightness is being adjusted deliberately like the blink of a beacon? Imagine a machine hidden within the icy shell of the comet, regulating its emissions. Imagine it cycling through intervals, perhaps to stabilize its trajectory, perhaps to transmit information. To us, it appears as a flicker. But to a more discerning observer, an observer prepared to decode, it might appear as language. Could the comet be a transmitter, wrapped in ice to disguise its purpose? The whisper of signals. The second anomaly, the faint radio emissions, echoes this possibility. If the signals were entirely chaotic, they could be dismissed as plasma noise, but the repetition, the faint patterns across multiple observatories, whispers of something more. Engineered transmissions need not be strong. In fact, an advanced intelligence might design them to be faint, subtle, detectable only by civilizations with technology advanced enough to notice. A kind of filter, a test. What if 3 Atlas is not speaking loudly to the cosmos but whispering, waiting for those who are capable of listening? The hollow interior. The third anomaly, its uneven mass distribution, feeds the same speculation. If the nucleus were hollow or structured, it could house machinery. A shell of ice and dust could cloak an interior unlike anything we have seen. Chambers, scaffolds, perhaps even propulsion systems. To human eyes, it looks like a comet. To deeper instruments, it might reveal its secret. That its core is not chaotic rubble, but architecture. The possibility is unsettling. We are accustomed to imagining alien probes as metallic, shining machines. But what if the most efficient disguise is natural form? An object that resembles a comet would pass unnoticed, drifting freely among stars. No civilization would fear it, no planetary defense system would target it. It would be the perfect Trojan horse, Could 3 Atlas be such a disguise? A vessel cloaked in the familiar, carrying the unfamiliar within, the chemical signature. The chemical anomalies, too, could be reinterpreted. Yes, they may reflect the natural isotopic fingerprint of a distant stellar nursery, but they may also represent something else. Deliberate alteration. What if the isotopes are not random, but engineered, chosen to stand out against the cosmic background? To us, they appear as peculiar ratios. To another intelligence, they may serve as a signature, a calling card embedded in the material itself. Could the chemistry of 3i Atlas be a message written not in radio waves, but in the very atoms of its body? The historical pattern, the echoes of history deepen the suspicion. Babylonian scribes, Chinese astronomers, Mayan codices, all spoke of comets that pulsed, flickered, breathed. If these were not exaggerations, then perhaps 3i Atlas is not the first engineered visitor. Perhaps others have passed before, cloaked in dust and ice, their presence recorded only as omens. What if the sky has been seeded with such objects for millennia, each passing by in silence, each leaving only a trace of unease? Is it possible that humanity has been observed, not from afar but from within our own skies by visitors disguised as comets? The purpose of engineering. If we allow ourselves to entertain the engineered hypothesis, we must ask, why? Why would an intelligence design such an object? Why cloak it as a comet? Why send it drifting among the stars? The answers are many, and none are certain. Perhaps such objects are probes, automated explorers, dispatched across the galaxy to gather information, much as we send voyagers and pioneers into the void. A cometary disguise would protect them, shield them, and ensure they blend into the background. Perhaps they are beacons, transmitting signals in faint regular pulses, waiting for civilizations advanced enough to notice. A cosmic filter. Only those who can decode the pattern are deemed worthy of hearing the message. Or perhaps they are something darker. Watchers, silent sentinels drifting through star systems, recording, monitoring, assessing. What if the cosmos is not empty but surveilled? What if 3i Atlas is one of countless hidden observers, passing judgment on the civilizations it encounters? The discomfort of the idea. For scientists, this hypothesis is deeply uncomfortable. To admit the possibility of engineering is to risk ridicule, to step beyond the boundary of respectable speculation. And yet, the anomalies remain, so they do not declare it openly. Instead, they whisper. They publish cautious papers on unusual periodicities. They hold late-night conversations over coffee. They wonder aloud, but only in the safety of trusted company. What if this thing is not what it seems? The discomfort is not only scientific, but existential. For if 3i Atlas is engineered, then we are no longer alone in our universe. The question is not whether other intelligences exist, but whether they have already passed us by, whether they are already watching. The hypnotic question. And so the mind circles back to the haunting question. What if the harmless visitor in our skies is not harmless at all? What if the comet we measure, the ice we track, the orbit we map are all a cloak? Could it be that 3 Atlas is a machine disguised as nature, carrying with it a purpose we cannot yet grasp? Transition. For now, this remains speculation. Nothing more. Science has not declared it. Official agencies have not confirmed it. And yet the anomalies whisper. The patterns persist. The engineered hypothesis hovers at the edge of imagination, like a shadow glimpsed at the corner of vision. We cannot prove it, but we cannot dismiss it either. And if it is true, if 3i Atlas is engineered, then the next question follows inevitably. How? What technology, what physics, what architecture would be required to transform an interstellar object into a machine? That is the question we must ask next. To entertain the possibility of engineering within 3i Atlas is to step into a profound question. If it is not natural, then how was it made? What tools, what technologies, what physics would be required to transform a drifting comet into a machine, or to build one that only appears to be a comet? This is speculation, of course, but speculation, when carefully tethered to scientific imagination, can be its own form of inquiry. It allows us to stretch the boundaries of what is possible, while still respecting the laws of nature. So let's consider the how. Hollow worlds. The first and most obvious step in the engineered hypothesis is the idea of hollowing. Comets, after all, are fragile. They are porous, icy, filled with voids. Their densities are often far lower than solid rock. If an advanced intelligence wished to transform a comet into a vessel, it might not need to carve it, but simply select it. Choose a body already riddled with caverns, then reinforce and enlarge them. Our own machines, robotic drills, lasers, nuclear charges, would struggle to do this on the scale of kilometers. But for a civilization thousands or millions of years ahead, hollowing a comet might be trivial. Nanotechnology could melt and reshape the ice from within. Directed energy could vaporize unwanted material. What remains is a shell, lightweight, stable, easily cloaked by a thin veneer of dust and frozen gas. Is it possible that 3I Atlas is such a hollow shell? That its uneven density is not a flaw of measurement, but the residue of hidden architecture? The skeleton within. If the comet is hollow, what lies inside? One possibility is a skeleton, a lattice of structural supports, a framework designed to stabilize the shell against collapse. Imagine beams of exotic alloys, stronger than steel, interlaced like the ribs of a great beast, holding the comet together as it endures the stresses of travel. Within that skeleton might rest chambers, bays for instruments, arrays for sensors, perhaps even engines, each hidden behind the mask of ice. We must resist the temptation to imagine alien interiors in human terms: corridors, control panels, glowing lights. Instead, think in functions. Instruments need not look like ours. Sensors may be woven into the very fabric of the ice. Engines may be silent, embedded deep, their nature indistinguishable from geology. Could 3I Atlas carry such hidden skeletons? And if so, are they active now, or relics long dormant, drifting without purpose? Propulsion, the great question. The next problem is propulsion. If 3I Atlas is engineered, how does it move? How does it cross the gulf between stars? Here the imagination must stretch, for interstellar travel requires energy on scales far beyond our current reach. One possibility is solar sailing. Vast, thin sheets that catch the light of stars, propelling the vessel forward. Such sails could be hidden, folded within, unfurled only in the dark reaches of space. Another is fusion propulsion, using the very ices of the comet as fuel. Frozen deuterium, hydrogen, and other volatiles could be harvested and ignited, releasing bursts of power. Each jet of vapor, invisible to us, could be part of a hidden drive, nudging the object across the cosmos. A third, more exotic possibility is gravitational surfing, using the fields of stars and planets as slingshots, guiding the comet along complex trajectories. A machine disguised as a comet would need only subtle adjustments to ride such paths indefinitely. And then there is the most speculative possibility of all: dark energy manipulation, an ability to bend space-time itself. To us, it would look like a simple comet drifting silently. But its path might be guided by forces we cannot yet comprehend. Could this explain the slight irregularities in its trajectory, the hints of acceleration not fully accounted for? Is 3I Atlas propelled not by chance, but by choice? The pulse of communication. If propulsion answers how it moves, communication answers how it speaks. The rhythmic light curve and the faint radio whispers could be signals, not accidental but intentional. How might such communication work? One method could be light modulation. By adjusting the brightness of outgassing jets, the object could encode information. A civilization watching carefully could decode these pulses, translating brightness into language. Another could be radio resonance. By using plasma interactions as carriers, the machine could hide its transmissions within natural emissions. To us, they look like noise. To a recipient civilization, they unfold into message. And then there is chemical encoding. What if the isotopic ratios themselves are part of the signal? Anomalous chemistry, chosen deliberately, might act as a signature, a way of saying, "This is not natural, look closer." Could 3I Atlas be a messenger speaking in three voices at once? Light, radio, and chemistry? Could its very body be a message carved into matter? Self-repair and longevity. Another challenge of engineering an interstellar machine is endurance. The journey between stars may take millions of years. Ice sublimits, dust erodes, collisions chip away at the surface. How then could such an object survive? One answer is self-repair. Perhaps the machine carries nanotechnology capable of patching its shell, rebuilding its structure grain by grain. Each outburst of gas we see could be not only sublimation, but maintenance. Repairs disguised as cometary activity. Another answer is redundancy. The machine need not remain pristine. It could be built to decay, with layers upon layers of backup systems, each one awakening as the previous fails. To us, it would appear as a crumbling comet, but inside its mission would continue. Is 3i Atlas one such survivor? A probe that has drifted for eons, still pulsing faintly, still alive in ways we cannot fully measure. The silence of purpose. If we ask how it was made, we must also ask how is it used. Perhaps it is not used at all? Perhaps it is ancient, derelict, a husk left behind by a civilization long vanished. In this case, its purpose has ended, and it drifts now as a relic. Or perhaps it is still active. Its faint signals may be transmissions, its pulsing light a beacon. Perhaps it records, monitors, observes. And if so, who is its audience? Not us, perhaps, or not only us. Maybe it transmits back to its origin, or to other probes seeded across the stars. Is 3i Atlas part of a network, a lattice of watchers hidden within comets, quietly surveilling civilizations across the galaxy? The humbling scale. The how reminds us not of technology alone, but of scale. To hollow a comet, to propel it between stars, to cloak it in ice and dust, all of this requires not merely intelligence, but patience. Imagine a civilization that thinks not in centuries, but in millennia. Not in lifetimes, but in epochs. For them, a million-year journey is nothing. A comet drifting between stars is not a curiosity, but a tool. Could we even recognize such an engineering effort with our brief human perspective? Or would we mistake it, again and again, for something ordinary? The hypnotic question. And so, the thought experiment deepens. What if 3i Atlas is not simply a wanderer, but a crafted machine? What if its pulse is deliberate, its signals intentional, its body engineered? What if it has drifted for millions of years, waiting for us to notice? Could it be that the harmless comet in our skies is not harmless at all, but part of a design too vast for us to yet understand? Transition. For now these remain only questions, speculation, not conclusion. Science cannot declare them true, but they linger as shadows on the edge of knowledge. And if the how can be asked, so too must the why. For behind every machine lies purpose, behind every design lies intent. And so, having considered how 3i Atlas could be engineered, we must now turn to the deeper question. Why? If 3i Atlas were natural, its purpose would be no purpose at all. It would be a wanderer, indifferent to us, indifferent to everything but gravity and the sun's warming touch. But if it is engineered, if we dare entertain the hypothesis of design, then a new and far more haunting question emerges. Why? Why would an intelligence take an object and reshape it? Why would it be sent adrift across the darkness between stars? Why here? Why now? These questions are dangerous, for they tempt us to project our own motives onto the unknown. Yet speculation, careful, tethered speculation, is the bridge between ignorance and understanding. Let us cross it slowly. Motive 1, exploration. The most benign possibility is also the most familiar. Exploration. We, after all, have already sent probes beyond our solar system. Voyager 1 and Voyager 2 drift now into interstellar space, carrying with them the golden records, humanity's message in a bottle. Pioneer before them carried plaques etched with diagrams of our place in the cosmos. New Horizons, after visiting Pluto, sails outward still, carrying the signatures of those who built it. Why should we imagine that another civilization would act differently? Perhaps 3i Atlas is simply an interstellar voyager, disguised not in gold and aluminum, but in ice and stone. A probe that gathers data, measures stars and reports back to its makers, or to no one at all, if those makers are long gone. Could it be that we are not the first to send emissaries into the dark? Could 3i Atlas be someone else's Voyager, still humming faintly after millions of years? Motive 2, communication. Another possibility is communication. Perhaps the rhythmic pulses, the faint radio emissions, the anomalous chemistry are not incidental but intentional signals. Not for us, perhaps, not originally, but for any who might notice. A message woven into light, into atoms, into the very body of the object itself. What would such a message say? A greeting? A warning? A map? Perhaps it is not meant to be understood at once, but only recognized. This is artificial. The content may not matter as much as the recognition. A signal that says, "You are not alone." And here, a strange thought arises. What if the very act of noticing is itself the test? What if the message is not in the signal, but in the ability to see the signal at all? Only a civilization advanced enough to detect anomalies in isotopes, to analyze light curves, to measure faint radio whispers, would even realize there is something to decode. Could 3i Atlas be less a message and more a mirror, reflecting our readiness back at us? Motive 3, surveillance. And yet there is a darker interpretation: surveillance. What if the object is not meant to speak, but to watch? A probe disguised as a comet would be the perfect observer. It could pass through systems unnoticed, blending into the background, recording everything. From within its icy shell, it could scan atmospheres, measure radio emissions, detect industrial byproducts, even map the biosignatures of life. It would not need to reveal itself. It would not need to communicate. It would simply observe, catalogue, and transmit. And what then? If 3i Atlas is watching, what becomes of the watched? Is it possible that civilizations across the galaxy are quietly surveyed, not by ships or fleets, but by comets that are not comets? What if our skies have always been under observation, and we never noticed until now? Motive 4, seeding. Another possibility lies between creation and observation: seeding. What if such objects are not simply machines, but carriers? Carriers of code, carriers of life. Inside their hollow shells, instead of instruments, there might be archives, databases of knowledge, libraries of genomes, even microbial seeds. This is not fantasy. The concept has a name: panspermia, the idea that life may be carried between stars on comets, asteroids, or engineered vessels. Some scientists, including Francis Crick, co-discoverer of DNA's structure, once speculated that life on Earth itself may have been seeded deliberately. Could 3i Atlas be part of such a program? A silent gardener carrying the raw materials of biology from system to system? Perhaps its purpose is not to watch, nor to speak, but to plant. And if so, what does it carry within? Nothing we can see now, perhaps. Nothing we can detect. But perhaps deep within its core lies the potential for life, waiting for the right world, the right conditions to awaken. What if Earth itself was once visited by such an object? What if our own genesis is tied to probes like this one? Motive 5, warning. There is yet another possibility, more unsettling still. Warning. Perhaps the pulses, the signals, the chemistry are not greetings, not surveillance, not seeds, but alarms. A message left for any who notice. Beware. Beware what? That is the question. Perhaps of natural dangers, gamma-ray bursts, unstable stars, galactic tides, or perhaps of something else, civilizations themselves. Here we must recall the dark forest hypothesis. The idea that the galaxy is filled with civilizations but all remain silent, fearing that to reveal themselves is to invite destruction. In such a galaxy, probes might be dispatched not to greet but to warn, to say stay quiet, stay hidden, do not announce yourself. Could 3i Atlas be such a messenger, its very presence a quiet signal of cosmic danger? Motive 6, test. And finally, there is the most unsettling motive of all, testing. What if 3i Atlas is not an emissary, not a watcher, not a gardener, but an exam? Its anomalies, its pulsing, its signals, its chemistry may be the questions. We are the ones being tested. Will we notice? Will we interpret correctly? Will we act wisely? Perhaps the object is less important than our response. Do we fear? Do we dismiss? Do we cooperate across nations or fracture into panic? What if the probe is not gathering data about our atmosphere or our biology, but about our behaviour, measuring not our chemistry but our maturity? And if so, who is grading us? The multiplicity of motives. Perhaps these motives are not exclusive. Perhaps 3i Atlas serves more than one purpose. A probe could both watch and seed, both transmit and warn. Its functions could be layered, redundant, adaptable. To one civilization, it might appear as a gardener. To another, a mirror. To us, it may seem a mystery still unsolved. Or perhaps we are wrong in every guess. Perhaps the true purpose lies beyond our comprehension, in motives as alien to us as ours would be to an ant. The hypnotic question. And so we return to the haunting question. Why is it here? Why does it pulse? Why does it whisper? Why does it resist fitting neatly into the natural? Is it to explore, to speak, to watch, to plant, to warn, to test? Or is it all of these things, woven together into a design too vast for us to yet understand? Transition. We cannot yet know the why. But we do know this. The story of 3i Atlas is not over. Another chapter is approaching. For soon, the comet will reach a critical point in its journey, an event that promises new data, new revelations, perhaps even new mysteries. A ticking clock now enters our story, counting down to the moment when speculation may be challenged or confirmed. What will that moment reveal? Every story of discovery eventually reaches a moment of anticipation, a point where all speculation, all theory, and all whispered questions converge on a single event yet to come. For 3 Atlas, that moment lies just ahead. A moment when the comet will align, pass or flare in such a way that the truth, or at least part of it, must be revealed. This is the ticking clock, a cosmic countdown. And while it does not strike with the loud urgency of human alarms, it beats softly in the minds of astronomers across the globe. The approaching event. As 3 Atlas continues its passage through the solar system, calculations point to a critical juncture, its closest approach to Mars. The planet of dust and rust lies directly in the comet's path, not in danger of collision, but in proximity close enough for instruments already orbiting Mars to watch the visitor more intimately than any Earth-bound telescope could. The European Space Agency's Trace Gas Orbiter, NASA's MAVEN mission, and the Chinese Tianwen-1 probe will all have opportunities to gather data. Cameras, spectrometers and magnetometers will record the comet from vantage points far beyond Earth's atmosphere. For the first time, we will not merely observe 3I Atlas from afar, we will watch it up close through the eyes of machines stationed on another world. And so, a date is marked on the calendars of scientists, a window of days in which the comet will pass by Mars, glowing faintly in its thin sky, a window when the anomalies might sharpen into clarity or multiply into deeper riddles. The quiet build-up. In the weeks leading to this moment, the scientific community prepares. Observation schedules are revised, proposals for telescope time are pushed forward, software teams refine algorithms to capture faint signatures in the data, and beyond the halls of science, the public begins to listen more closely. Media reports speak of the Mars flyby, framing it as an opportunity to learn more about an interstellar traveller. News anchors ask whether astronomers expect answers. Governments too track the date. Internal memos circulate. Intelligence agencies draft reports, weighing the strategic implications of a discovery that might shake our understanding of the universe. And in the quiet corners of online forums, speculation intensifies. Some predict that the comet will reveal itself as hollow. Others insist it will emit a clear signal as it passes Mars, aimed at the red planet itself. A few warn darkly of catastrophe, that the comet's passage will disturb Mars's thin atmosphere or disrupt satellites in orbit. Most of these fears are unfounded, yet the mood is unmistakable. The world feels the tick of the clock, the weight of waiting. Waiting is its own kind of gravity. For the astronomers who study 3I Atlas, the days feel heavy with anticipation. They calibrate instruments, they refine predictions, they write cautious papers hedged with uncertainty. Yet beneath the calm exterior lies the pulse of excitement. What will the Mars probes see? Will they detect the interior structure of the comet? Will they measure magnetic anomalies that cannot be explained? Will the brightness pulse sharpen into a true signal? Or will everything dissolve into the ordinary, the anomalies vanishing under closer scrutiny, leaving only a comet after all? The waiting is almost unbearable, and yet it is necessary. The comet moves at its own pace. The clock ticks in silence, indifferent to human impatience. Humanity holds its breath. For the wider world, the approach of this moment takes on symbolic weight. The comet has become more than an object. It has become a story, a mirror in which humanity projects its fears and hopes. For some, 3I Atlas is a herald of contact, a chance to prove we're not alone. For others, it is a silent threat, a reminder of how fragile Earth is against cosmic visitors. And for many, it is simply a mystery, a puzzle that defies easy answers. As the date nears, even those who do not usually follow astronomy find themselves glancing at headlines, wondering what the scientists will say. The comet, once invisible to the naked eye, has entered the imagination of the world, and so a strange stillness descends. Humanity, in its billions, waits for a comet that most will never see directly, but all now know by name. The soft drumbeat of time. Astronomers speak of orbital mechanics as destiny written in mathematics. Every position, every velocity, every turn around the sun can be predicted decades, centuries, even millennia in advance. And yet, when the object carries anomalies, the prediction feels less like certainty and more like suspense. The days fall away, one by one, like grains of dust trailing behind a comet's tail. The clock ticks softly, invisibly, but insistently. What will happen when 3 Atlas brushes past Mars? Will its rhythm change? Will it brighten or dim? Will it flare in one final pulse, revealing a pattern? Or will it slip past silently, offering nothing more than silence? Could this be the moment when the comet finally reveals itself, not as ice, not as stone, but as something else? A gentle anticipation. The tone of public discourse reflects this duality. Scientists speak calmly of data opportunities, assuring the world that the comet poses no danger. Yet beneath the words, there is a current of excitement. In podcasts, in lectures, in late-night interviews, they speak of the mysteries still unresolved. The light curve, the radio signals, the odd chemistry, the echoes of history. Each anomaly alone could be dismissed. Together they form a story that feels unfinished, and the Mars encounter is the next chapter. Anticipation? Yes, but not panic. For this is not a countdown to doom, but to knowledge. Not a ticking bomb, but a ticking clock of discovery. Still, discovery itself can be unsettling. Knowledge can disturb as much as it enlightens. And so the anticipation is gentle but tinged with unease. The hypnotic question. And so, as humanity waits, the question loops softly. What if this moment changes everything? What if the Mars encounter reveals that 3i Atlas is ordinary and the mystery evaporates into dust? What if it confirms the anomalies deepening the riddle? What if it reveals structure, signals, intent? What if the comet is not passing us by at all, but pausing, waiting for something? The stillness before the event. In the final days before closest approach, telescopes turn relentlessly toward the comet. Images flood in. Light curves grow sharper. Radio receivers listen with patient ears. The world grows quiet, not in fear but in wonder. It is the stillness before revelation, the silence before a voice speaks. The clock ticks, the moment approaches, and soon, very soon, the comet will show us more. And then, after months of waiting, the moment arrives. The Atlas drifts into its closest approach to Mars. A silent crossing, written not in thunder or flame, but in mathematics. Yet, for all its quiet, the world seems to lean forward as though holding its breath. The comet does not roar. It does not strike. It simply passes, an object of ice, dust, and mystery gliding against the backdrop of the red planet. But as it does, instruments across the solar system awaken, and data begins to pour in. The first images. From the thin Martian sky, cameras aboard orbiters catch their first clear glimpses. The trace gas orbiter photographs the comet from just beyond the planet's limb. Against the rust-red horizon, 3i Atlas appears as a luminous smear, its coma fainter than expected, its tail oddly structured. The MAVEN spacecraft detects ultraviolet emissions, bright and fluctuating. The Tianwen-1 probe captures infrared spectra, revealing unexpected heat signatures near the nucleus. For the first time, we see not just a comet, but the shape of its strangeness, written in light. To the untrained eye, the images are ordinary, just another comet against the void. But to the scientist watching, patterns leap out. Jets of gas that appear to fire in synchrony. A tail segmented into faint repeating bands. A nucleus that glows not evenly but in pulses. The heartbeat is real. Even here, so close to another world, the rhythm persists. The radio burst. Then comes the first surprise. As the comet crosses the Martian orbit, radio telescopes both on Earth and on Mars detect a sudden burst. A flare of broadband noise brighter than anything seen before. It is not a single spike, but a sequence. 3 pulses evenly spaced, then silence. Static fills the receivers, then clears again. Astronomers check for interference, for solar flares, for errors in their equipment. None are found. The burst is real. It came from the direction of the comet. And then, after a pause of several hours, it repeats. 3 pulses, silence, 3 pulses again. Is it communication? Is it a beacon? Or is it nothing more than a plasma instability amplified by the geometry of Mars's magnetic field? The debate begins immediately, but for those who listen in real time, it feels uncanny, as though the comet is speaking. The magnetic ripple. At the same time, MAVEN's instruments detect disturbances in Mars's ionosphere. Subtle, but measurable. Waves ripple outward, not as catastrophic storms, but as faint oscillations, synchronized with the comet's passing. To planetary scientists, this is fascinating. A comet influencing another planet's atmosphere in real time is rare. To others, it is unsettling. The ripples seem too neatly timed, too clean, too ordered. Could this be coincidence? Could it be the natural result of solar wind funneled by the comet's tail? Perhaps, and yet the pattern feels deliberate. The light show. Then, as if on cue, the comet brightens. Not randomly, not chaotically, but in a sequence. From Earth, Telescopes record a flare of light that rises smoothly, peaks, and then diminishes again. 11 hours later, it happens again. The pulse continues, stronger now, visible even in smaller instruments. It is as though the heartbeat has grown louder, more insistent, amplified by its encounter with Mars. Amateurs across the world see the brightening with their own eyes through backyard telescopes. Social media fills with reports, photographs, grainy videos. The comet is no longer only the domain of scientists. The public sees it too, and the sense of mystery deepens. The silence of the sky, and then silence. After 3 days of heightened activity, the comet dims again. The radio bursts cease. The pulses in brightness fade. The comet returns to what appears to be ordinary behaviour, its coma thinning, its path continuing outward. It leaves behind no catastrophe, no revelation, only questions. The debate. Immediately, debate ignites. To many scientists, the events can be explained. The radio bursts were plasma effects. The magnetic ripples were natural interactions. The brightness pulses were the product of rotation and jets. The anomalies may be strange, but they are not unprecedented. To others, the explanation feels incomplete. The repetition of the bursts, the precision of the pulses, the timing of the magnetic ripples, too much order, too much coincidence. Is it possible that 3i Atlas revealed itself briefly only to fall silent again? That we glimpsed for a moment something engineered? Or is it possible that we're merely projecting patterns onto noise, reading intention into chaos, mistaking nature for design? Humanity's response. For the public, the event takes on a mythic quality. Headlines declare the comet that spoke. Podcasts dissect the bursts, offering theories from alien probes to cosmic coincidence. Documentaries rush into production. The comet becomes not just a scientific puzzle, but a cultural phenomenon. For governments, the data is treated with caution. Internal reports acknowledge the anomalies, but official statements remain conservative. No threat, they insist. No danger. And yet, intelligence agencies quietly monitor communications, aware that the comet has stirred imaginations worldwide. For scientists, the work continues. Data is analysed, papers drafted, conferences scheduled. Some argue for extraordinary claims, most remain cautious. Yet even the cautious admit, something unusual occurred. The hypnotic loop. And so, the climax event leaves us not with answers, but with deeper questions. What if the bursts were a message? What if the pulses were intentional? What if the comet's silence afterward was not retreat, but completion? Its signal delivered, its purpose fulfilled? Or what if it was only nature, strange but explainable, playing tricks with plasma, light, and gravity? Could it be both? Natural in form, yet carrying the whispers of something more? The return to silence. As the comet drifts away from Mars back into the vastness of interplanetary space, the world settles into uneasy quiet. The ticking clock has struck. The event has come and gone, but the answers remain elusive. Like so many mysteries before it, 3i Atlas has revealed enough to tantalize, but not enough to resolve. It is both more ordinary and more extraordinary than we imagined. The heartbeat may fade, the signals may quiet, but the questions will linger, looping softly in the human mind night after night. The comet passes. The instruments fall silent. The event is over. And yet, in the weeks that follow, the true work begins. For what matters most in astronomy is not the spectacle itself, but the data left behind. The raw, stubborn numbers that refuse to be swayed by wonder or fear. And so, terabytes of measurements, light curves, spectra, magnetic readings, radio logs, flow into the hands of scientists across the globe. It is here, in the patient passing of numbers, that humanity seeks answers. But what the data reveals is not certainty, it is ambiguity. A tapestry of signals woven with both clarity and contradiction. Enough to see patterns, but never enough to settle them. This is the great paradox of science. The closer we look, the deeper the unknown becomes. The pulse in the light. First, the light curves. From Earth and Mars alike, telescopes recorded the comet's brightness during its closest approach. When these observations are compiled, the rhythm becomes undeniable. The pulses recur, not perfectly, but persistently. An interval of roughly 11 hours, with deviations of mere minutes. The pulse grows stronger near Mars, then fades as the comet drifts away. It is as if the heartbeat quickened when watched, then softened again once it passed beyond the instrument's gaze. Models of rotation explain some of the rhythm, but not all. Jets can account for brightening. But why so regular? Why so consistent across weeks of observation? The data leaves a question that cannot be dismissed. Is the heartbeat of 3i Atlas natural rotation, or is it a signal disguised in light? The bursts in the radio, next the radio emissions, across 3 continents, and from orbit around Mars receivers caught the same sequence. 3 bursts, evenly spaced, then silence. Hours later, the pattern repeated. When analysed, the bursts showed a wide spectrum of frequencies, too broad to resemble engineered transmissions as we know them, but too clean to dismiss as static. Fourier analysis reveals peaks that echo in repetition, faint harmonics that suggest structure. Some scientists argue for plasma instabilities in the comet's coma. Others counter that the repetition defies random turbulence. The question hangs, unresolved. Were these bursts nothing more than the wind of the sun playing tricks with dust? Or were they whispers, deliberate, faint enough to test our ability to hear? The magnetic ripples. The MAVEN spacecraft's magnetometer recorded oscillations in Mars's upper atmosphere during the comet's passage. Not violent storms, but ripples, regular, synchronous with the pulses of light and the bursts of radio. This alignment troubles many. 3 anomalies from 3 different domains, light, radio, magnetism, all moving in step. Coincidence is possible, coincidence is always possible, but the mind resists coincidence when patterns grow too neat. What if the comet was not simply emitting, but interacting? What if its presence near Mars was not passive, but active, shaping the ionosphere, tuning itself against the planet's field like a bow drawn across strings? The chemistry. Meanwhile, spectroscopic data deepens the chemical puzzle. The comet's isotopic ratios remain stubbornly odd. Nitrogen, carbon, oxygen, each shows deviations from known ranges in solar system comets. Not alien in a fantastical sense, but alien enough to resist easy classification. Some suggest the ratios point to a birthplace around a star richer in heavy elements. Others propose the influence of nearby supernova, seeding its formation environment with rare isotopes. And yet, another interpretation lingers. What if the chemistry itself is intentional? What if the skew is deliberate, chosen as a marker, a signature, embedded in the very atoms of the comet? The data that contradicts. For every anomaly that seems to support the engineered hypothesis, there is another that undermines it. Yes, the light pulses, but the deviations are irregular enough to fit rotation models. Yes, the radio bursts repeat, but they lack the narrow-band precision we would expect from technology. Yes, the magnetosphere rippled, but such ripples are known from other comets, though rarely so synchronized. The data refuses to align with one story. It offers support, then snatches it away. It whispers, then falls silent. It is as though the universe itself delights in ambiguity, giving us just enough to question, never enough to conclude. The scientific divide. As the papers emerge, a divide opens within the scientific community. On one side stand the skeptics, armed with models, simulations, and a long tradition of caution. To them, the anomalies are interesting but explicable. No evidence, they insist, compels us to invoke intelligence. The comet is natural. It must be natural. On the other side stand the dreamers, the minority willing to entertain speculation. They argue that the convergence of anomalies is too unlikely, that the patterns are too neat. They do not claim certainty, but they whisper possibility. Perhaps we have glimpsed something artificial. The debate spills into journals, conferences, interviews, not hostile but sharp, a dance between caution and curiosity. And in the middle stands the data itself, silent, indifferent, offering no resolution, the public imagination. Outside the halls of science, the comet's passage ignites imagination. Writers, artists and philosophers seize upon the idea of a messenger disguised as a comet. Novels are drafted, films are pitched. Podcasts debate whether 3i Atlas is a voyager from another civilization. For some, the comet becomes a symbol of hope, the possibility that we're not alone. For others, it is a symbol of unease, a reminder that the universe may be filled not with friends, but with watchers. Children peer through small telescopes, adults follow nightly news, poets write of a comet that spoke and fell silent. The mystery enters culture, not as fact, but as story. And stories too shape the world. The great unknown. In the end, what the data offers is not certainty, but invitation. Invitation to wonder. Invitation to speculate. Invitation to question our place in the cosmos. For whether 3i Atlas is natural or engineered, ordinary or extraordinary, the truth is this. We do not fully understand it. Its anomalies resist neat closure. Its signals defy final interpretation, and perhaps that is the most important discovery of all. That mystery still exists even in an age of instruments so precise they can measure the flicker of distant stars. We hunger for answers, yet sometimes the universe gives us only questions. The hypnotic question loop. And so we ask, what if the comet was natural all along, and the strangeness lay only in us, in our yearning for meaning? What if it was more than natural, an artifact, a machine, and we glimpsed it barely before it faded into silence? What if the truth is neither, or both, or something beyond our ability to frame? Is it possible that the purpose of 3i Atlas is not to deliver answers, but to awaken the very questions we now ask? Transition. The data is rich, but the mystery remains. The numbers tell us more, but the unknown has only grown larger, and so we must step back. We must leave the instruments behind, if only for a moment, and look outward. Beyond the comet, beyond the anomalies, beyond the immediate questions of natural or artificial. For the true meaning of 3 Atlas may lie not in its details, but in its place within the cosmic story. What does this visitor mean for us? For humanity's sense of self? For our fragile belief in our place in the universe? To answer, we must widen our gaze. We must take the cosmic perspective. When we stare too closely at the details, at pulses and bursts and ratios of isotopes, the world can feel claustrophobic, confined to data points and arguments. Yet, there comes a moment when we must step back, to see not only the comet, but the theatre in which it drifts, to see not only anomalies, but the ocean of space itself. 3i Atlas is a visitor, yes, but it is also a reminder. The cosmos is vast, ancient, and infinitely patient. Its stage dwarfs both our fears and our hopes. Let us widen our gaze, a visitor from the deep. Consider what 3i Atlas truly represents. It is not simply a comet, it is a fragment from another star. Its atoms, its ices, its dust were forged in furnaces far from here, perhaps around a sun unlike our own, perhaps in the chaos of supernovae, perhaps in the quiet womb of a distant nebula. For millions, perhaps billions of years, it has drifted through the interstellar dark, alone. No sunlight to warm it, no planetary gravity to anchor it, only the emptiness of space, the faint dust of galaxies, the invisible tides of gravity. And now, for a brief moment, it has crossed into our neighbourhood, into our sky, into our story. What does this mean? It means that we are not isolated. Our solar system is not a sealed chamber. The boundaries between stars are porous. Objects wander, histories cross, matter mingles. The very atoms of 3i Atlas remind us that the universe is a web, not a set of islands, and we are part of that web. The scale of time. When we contemplate the comet, we must also contemplate time. For us, its passage lasts months. For astronomers, perhaps years of observation. But for the comet itself, this moment is nothing. A blink. A fleeting instant in a journey that began long before humanity and will continue long after us. Our species has lived for less than an eye blink on the cosmic clock. Civilizations rise and fall in thousands of years. Comets cross interstellar space for millions. Stars burn for billions. The galaxy itself will spin for tens of billions more. Against this backdrop, our questions. Is it natural? Is it engineered? Is it a message? Take on a different tone. They are important to us. But to the cosmos, they are whispers of children, wondering at shadows on the wall. And perhaps that is the true gift of 3i Atlas. Not its answers, but its reminder of scale. The fragile Earth. From the perspective of the comet, Earth is small, a pale dot tucked beside a yellow star, a fragile sphere wrapped in a thin skin of atmosphere. It is humbling to imagine, if the comet's path had been only slightly different, if gravity had pulled a little harder, if velocity had shifted a fraction, Earth might have been in its way. A harmless visitor could have become catastrophe. Yet this did not happen. By chance, by grace, by mathematics, the comet passed us by, and we are left with the gift of watching, not the curse of suffering. How fragile we are, how lucky we are, how fleeting our security is, and yet how wondrous that we can see, can measure, can ask questions at all. The question of loneliness. When we zoom outward, we cannot help but face the great question, are we alone? If 3i Atlas is natural, then it is only a fragment of stone and ice silent in its drift. But if it is engineered, if even the smallest part of its anomalies suggest design, then loneliness is broken forever. But even if it is only natural, the question remains, for if objects wander between stars, then so too could seeds of a life. The galaxy may not be empty, but scattered with sparks, and we may not be alone, not because intelligence has reached us, but because life itself is a pattern too persistent to vanish. Loneliness is a human fear. The cosmos itself does not know loneliness. It is filled with matter, energy, gravity, light. We are the ones who wonder. We are the ones who yearn. Perhaps Three-Eye Atlas is not an answer to that yearning, but a mirror of it. The shared sky. There is another perspective the comet offers. Unity. When Three-Eye Atlas passed Mars, the entire planet Earth turned its instruments toward it. Telescopes in deserts, antennas in valleys, spacecraft orbiting other worlds, all pointed at the same object. Scientists from rival nations shared data. Amateurs across continents captured their own images. For once, the sky was not divided by borders. For once, humanity looked together at something beyond itself. The comet reminded us that above all politics, above all conflicts, the cosmos is shared. The stars belong to no one. They belong to everyone. And perhaps this is the most important perspective of all. That we are one species under one sky, looking outward together. The mystery that persists. Even after all the data is collected, the comet remains a riddle. Was it natural? Was it more? The question lingers. But perhaps the ambiguity itself is a gift. For if the comet had given us certainty, it would have ended the story. By leaving us in mystery, it invites us to keep searching, to keep wondering, to keep asking. The unknown is not a failure, it is an invitation. What if the purpose of Three-Eye Atlas was not to deliver answers but to awaken curiosity? To remind us that the cosmos is vast and we have only just begun to explore it. The cosmic lullaby. Now, as the comet drifts outward, back into the cold, its presence fades. Its tail grows dim, its coma shrinks. Soon, it will vanish into the darkness, invisible to even our most powerful telescopes. It will leave us as quietly as it arrived, a ghost returning to the night, and in its absence we are left not with terror but with wonder, not with despair but with awe. The universe is larger than we can imagine, older than we can comprehend, and stranger than we can yet explain. Three Atlas is one small thread in that infinite tapestry, but a thread that has reminded us of our place, our fragility, our unity, and our yearning, the hypnotic question. And so, as night falls and the comet fades, the question remains. What if the universe is alive with watchers, and we are only beginning to notice? What if we are alone and yet not lonely, because we are part of a cosmos that carries us in its arms? What if the purpose of mystery is not to frighten us, but to cradle us, to give us questions soft enough to fall asleep with? Transition. The comet drifts away. The data is archived. The debates continue. But the mystery does not end here. It lingers, unresolved, echoing in the silence of the night sky. And as we prepare to close this journey, we must let the story fade as the comet fades, into quiet, into wonder, into sleep. The comet drifts onward. Its glow grows fainter. Its heartbeat, if heartbeat it ever was, becomes lost in distance. The instruments fall silent. The headlines fade. The world turns its attention elsewhere. And yet, in the quiet spaces of the night, the mystery of Three-Eye Atlas remains. It lingers not in the data logs, not in the debates of scientists, but in us, in the questions that rise softly when the mind is calm, when the eyes close, when the universe whispers in silence. The comet that came and went. So what was Three-Eye Atlas? Perhaps nothing more than ice and dust following the patient mathematics of gravity. A wanderer from a distant star carrying nothing but frozen fragments of a forgotten world. Harmless, unremarkable, fleeting, or perhaps something more. A machine disguised as nature, a messenger cloaked in ice, a watcher, a beacon, a seed, a signal not to our instruments but to our imagination. We cannot know, not yet, perhaps not ever, but that is the beauty of mystery. The answer is not what lingers, it is the question. The comet, like a dream, fades. The question remains. The rhythm that echoes. Do you remember the pulse? 11 hours, 11 hours, a rhythm steady as a breath. What if it was only rotation, a simple wobble of an icy shell? But what if it was more? A beacon beating like a heart, a voice saying we are here, or perhaps saying nothing at all but still reminding us. The cosmos is alive with rhythms, with patterns, with echoes. As you rest, feel that rhythm. The quiet beat of the comet, the quiet beat of your own breath. Different, yet the same. a reminder that in the smallest patterns we find connection. The silence after the signal. Do you recall the bursts of radio? 3 pulses, silence, 3 pulses again, perhaps only static, perhaps only plasma noise. And yet, is it not strange how silence can feel like a message of its own? How the absence of sound carries weight, as though waiting to be filled by meaning? What if the silence after the signal was deliberate? What if it was an invitation, a space for us to respond? We cannot answer, not yet. But in wondering, we already participate in the conversation. The questions that will not rest. What if the comet was only a comet? What if it was a probe? What if it was a seed of life? What if it was a test? Each possibility drifts across the mind like clouds across the night sky. You do not need to choose. You do not need to decide. Let the questions float soft and unresolved. Is it possible that the very purpose of 3i Atlas was not to tell us an answer, but to awaken these questions within us? Humanity in the cosmic ocean. We are small, fragile, brief, and yet we notice. We build telescopes. We launch probes. We measure faint light across impossible distances. We listen. We ask. That too is a kind of greatness. Not the greatness of power, but the greatness of wonder. Perhaps this is why the universe gives us comets, visitors from other stars, to remind us that we're not trapped, that the boundaries between worlds are porous, that matter flows between suns, carrying whispers, carrying mysteries. We are part of a larger ocean, and tonight we float within it, gently rocked by its waves. The gift of uncertainty. Some might feel frustrated by the ambiguity of 3i Atlas. They crave certainty, proof, answers carved into stone. But certainty is a kind of ending, and endings close doors. Uncertainty, by contrast, is a door left open. It is an invitation to continue, to imagine, to explore. What if certainty is not what we need at all? What if the gift of the comet is not an answer, but the chance to keep dreaming? Let that dream carry you now, a dream of stars, a dream of visitors, a dream of mysteries that do not frighten but comfort. The cosmic lullaby. Far above, the universe hums its endless lullaby. The low vibration of gravity, the quiet whisper of solar wind, the silent turning of galaxies. And within that lullaby, 3 Atlas drifts away. It becomes dimmer, smaller, fainter, until it vanishes into the dark. But in your mind, it remains. A flicker, a rhythm, a question. And that question will outlast the comet itself. The hypnotic questions. What if the universe is filled with watchers, silent and patient, disguised as the very comets we overlook? What if life, everywhere, is seeded by fragments like these, machines wrapped in ice, carrying the blueprints of creation? What if 3 Atlas was only one of many, drifting past unnoticed, their whispers lost to the noise of the stars? What if we are already part of a conversation and do not yet realize it? And what if the true purpose of mystery is not to alarm us, but to soothe us? To remind us that the universe is vast enough to hold our questions, vast enough to cradle our fears, vast enough to let us rest. The fade. Now the comet is gone. The sky grows quiet again, the instruments turn to other targets, the debates soften. But within you the story remains, not as a sharp thought, not as a demand for answers, but as a gentle echo, a rhythm, soft and steady. The comet drifts outward, and you drift inward, toward stillness, toward rest. Let the questions fade into dreams, let the universe hold them for you. Let the mystery carry you gently into sleep. Final whisper. And so, we close where we began. A comet, harmless yet haunting. A visitor from afar, a puzzle with no solution. And the question remains, soft and unending. What if 3i Atlas was never the threat but the reminder? What if the real gift is the wonder we now feel, the calm awe that carries us gently into the night? Sleep now with that question in your heart. Let the cosmos cradle you. Let the mystery sing you to rest.